All right, the next section, which is 4.5, is difficult. No question, it's a difficult section. Because you have to picture in your head a 3D graph. Up to this point, you've only ever done 2D graphs, where this is x and this is y, and everyone's happy, it's easy. But when we talk about 3D, and this represents a plane, because even if you have a piece of paper, anytime you have length and width, you're basically working with this type of Cartesian graph. Just normal, two-dimensional, yada yada, easy. But in this section, we're going to start talking about z. And z represents height. So in this situation, z would come out of here. Like, it would be how high it is. It wouldn't just be that two-dimensional graph anymore, it's three-dimensional. I think this might pose some problems, but I'm not sure how much time to spend on it. I think that reading through this section, reading through it, would make life easier for you, period. So when you have some important things to remember, when you have 2x plus 3y plus 4z equaling 12, the x can represent the length, say. The y can represent the width, and the z can represent the height. This is representing a plane in space. It's a plane, it's not a line. For example, 3x plus 4y equals 7. This is a line. It has width, it has length, right? Or it has, you can call these dimensions whatever you want, but it's only two-dimensional, it's a line. This one has three dimension. It's a plane now. That's why we talk about dimensions so much. And a point, like for example, x equals 3. Well, if we have a number line for x, 0, 1, 2, 3, that's just a point. That's one dimension. Just one dimension. This is a line. It has two dimensions. This is a plane. It has three dimensions. So it's important to understand that. Then looking at the graphs and trying to wrap your head around the graphs for this type of thing is very important. But probably the one thing that I want to make sure that we go over is that XY trace. You have an XY trace, you have a YZ trace, you have a ZX trace. Basically, those are just finding your intercepts. It sounds like a lot, but it's not that big of a deal. Let's take a look at it real quick. Here we have, they've given us the equation to start with of 2x plus 3y plus 4z equaling 12. So in this situation, I'm going to go ahead and find my intercepts of x, y, and z. If I make my y and z 0, I would get 2x plus 0 equals 12. Well, that will mean that x is 6. Now I'm going to do the same thing. I'm going to set my x and z equal to 0 and figure out what y was. So we have 0 plus 3y plus 0 equals 12. So 3y equals 12. Y would have to equal 4. And I'm going to do my z trace this one the same way. 0 plus 4z equals 12. So 4z must equal 12. Z must equal 3 there. Now, we're going to go ahead and plot the xy plane the same way we've always done. Here's my x, here's my y. So, when we talk about the axis of the, let's do this first. So my my x-intercept is 6, 0. 1, 2, 3, 4, 5, 6. My y-intercept is 0, 4. 1, 2, 3, 4. Now imagine we had another stick coming out of the ground. Let's just use this as my stick. That would be my z, and that would be up 1, 2, 3. And this would be how it would be. This would be that point. If I had this point sitting here, and I put one edge of the paper here, one edge of the paper here, and one edge of the paper at 3, I would have graphed my plane. That's the plane that this line represents. It might be tough, stick it out, make sure you read the section. It's got a very small number of problems, only 5. This may be one of those days that you and John, or John and Daniel, you want to get together and you want to discuss this. See, this is 5, which is Thursday's work, I think we might have a game that night, so you might be able to get together and talk with each other at that game. All right, good luck.